Hello friends, welcome to another practice question of quadratic equations. This is the 101st question in the series. I will strongly urge you to go back and watch the previous 100 videos and all the theory videos. The link to the entire playlist is down there in the description for your reference. Now remember, this is an HOTS question, which means this is a higher order thinking skills question. So to finally get the answer, we'll have to apply some thinking skills other than the usual formula method. Okay, let's start solving this one. And the first step in solving this question is to actually simplify. Now you see this is actually asking us to find the roots of the equation. Prove that both the roots of the equation are real, but they are equal only when a equal to b equal to c. So this is a question on the nature of roots. Okay, this is a question on the nature of the roots, and he is saying that we have to prove that the roots are real, but they are equal only when a equal to b equal to c. So we have to find the condition that d is equal to 0. Under what condition will d be equal to 0? But to check that, we have to first bring this question in the standard format, and the standard format is ax square plus bx plus c equal to 0. Simplifying this is slightly complicated, so what I'll do is, when you multiply this, don't directly open, okay? In fact, open it in a 3-step. So you see, x minus a multiplied by x minus b will actually give you x square minus of x into a plus b. Okay, x square minus of x into a plus b and plus of ab. Okay, I'm just multiplying the first two terms, and this is what I get: x square minus of x into a plus b plus ab. For the second term, what it will give is x square minus of x into b plus c multiplied by plus bc. Okay, and for the third term, it will give, because these three are symmetrical in nature, minus of x into a plus c plus of ac. Okay, so this is what we get when we simplify the three terms. Now you see, all the three x squares I can actually add, and it will become 3 times of x square. Now all of these terms we can add, and it will become minus of 2x into a plus b plus c. I have tried to maintain the symmetry as much as possible. Now the third term is plus of ab plus bc plus ca. Okay, and if this is the quadratic equation which is equal to 0, this is equal to 0 here. If this is the quadratic equation, on this I can apply this formula and try and equate the d to 0. When I try to equate the d to 0, if d is equal to 0, this will imply that b square minus 4ac for this equation should be equal to 0, and this will mean, let me plug in the values of abc. So b here will be equal to b square will be equal to 4 times of a plus b plus c the whole square minus of 4 times of a, which is 3, into c, which is ab plus bc plus ca. Okay, I'm sorry, yeah, this is right. Okay, this is what I get. Now if I take the 4 out common, what I get is, if I take the 4 out common, what I get is a plus b plus c the whole square minus of 3 times of ab plus bc plus ca. And also remember that this value b square minus 4ac should be equal to 0, so this should be equal to 0 and this should be equal to 0, because we are trying to find real and equal roots. Okay, this 4 I can remove because I don't need this. Okay, the 4 cannot be equal to 0, so this should be equal to 0. Okay, this term inside this bracket, the whole thing should be equal to 0. Now I'm opening the brackets after removing the 4. It is a square plus b square plus c square plus 2ab plus 2bc plus 2ca minus of 3ab minus 3bc minus 3ca equal to 0, and this would become equal to a square plus b square plus c square plus, minus of ab minus bc minus ca equal to 0, and if I move the negative terms to the RHS, it will be a square plus b square plus c square is equal to ab plus bc plus ca. Now you see these two sides, the LHS and the RHS, are very symmetrical. Okay, they are very symmetrical. Now a square could either be equal to AB, or a square could be equal to BC, or a square could be equal to CA. Similarly, these two terms could be equal, and these two equalities are possible only and only if A equal to B equal to C. Okay, this symmetrical solution, this symmetrical equation will only and only have a solution if A equal to B equal to C. Otherwise, this symmetrical possibility is impossible. Okay, so remember this: the two sides, that is LHS and RHS, are going to be equal only and only in this symmetrical condition. They are going to be equal only and only if A equal to B equal to C. And this is the solution, my dear friends. I hope you found the solution useful. Do like, share, comment and subscribe. In case you want me to solve any other questions for you, do put down your queries at the WhatsApp number mentioned in the description. Till then, keep working hard, keep practicing hard. Cheers and God bless.